Hello guys, so today we will discuss how to design a circuit diagram for our digital clock with Arduino and DS1302 RTC. So this is the part 4 of our digital clock using Arduino series videos. So if you want to see the part 1, 2 and 3, please visit my channel and watch the other videos of this series so that you will be on board in the design, in the function, and how I program this digital clock. So in this video we will discuss in details how to design a circuit diagram for our digital clock. So things we need are: number 1, Arduino Uno, DS1302 module. DS1302 module has 5 pins. It can send time, including the date, days, month, year. We can reprogram it, and it has also a backup battery in case the supply voltage, the VCC, will be interrupted. This backup battery will serve as the source to maintain the supply, to continue the operation of this module, and of course to save the time, the current time, and to continue the time. So, and this for display 7 segment with part number is H5461ES. It is a common cathode 7 segment, meaning each of the segment, all the cathodes are connected, whereas the anode of each segments are supplied by individual source. It has 12 pinouts. The pin configurations are from left to right, then right to left. So pin numbers 1, 2, 3, 4, 5, 6, 10, 7, 8, 9, 10, 11 and 12. We need also limiting resistors for the cathode of the 7 segment display. It's in 1 kilo ohm. Then another 3 resistors that will be used for our pull down switch. Then we also need, of course, 3 ductile switch. This one will be used to set which of the segment will be adjusted. This one will be used for the increment, and this one will be used for the decrement. So we also need LED, just one LED that will serve as an indication of our sequence, and a limiting resistor of 200 ohm, 220 ohm of this LED. So I think, and lastly, of course, wires and the breadboard. Okay, so let's start. So here, as you can see, the pin outs and the circuit for the 7 segment display. pins 1 to 6, then 7 to 12. If you look at the datasheet for this module, you will find out that this pin number 12, number 9, 8, and 6 are the common cathode of each display. So we assign here a resistor, limiting resistor of 1 key. 1 key, 1 key, and 1 kilo ohm. So why 1 kilo ohm? So let's do some computation. An LED in order to light an red LED, you need at least 2 volts across 20 milliamps so that it will have a bright light. So this 2 volts is also called the forward voltage. So since our Arduino have an output of 5 volts, so this is the resistor, the limiting resistor. If you set that 2 volts here, then in this portion you will left with 3 volts. So plus 3 is equal to 5 volts as the source. So if you do mathematical computation with the value of this resistor, that's what we want to know. You will have a formula: resistor is equal to voltage over the current. So therefore the voltage for this resistor is 3 volts and the current flowing to this line is 20 milliamps. So you have 3 divided by 20 milliamps times 1000, so that is 150 ohms. 150 ohms. But why did I use 1 kilo ohms? Because remember that in the 7 segment there are also 7 LEDs, and since this module is, as what I said, common cathode, the electrical equivalent of this will look like this. There are 7 LEDs. All the cathodes are connected. And this will be the resistor that we are looking for in the ground. So since there are 7 of them, and we know that 150 ohms needed for each individual, so if you multiply 7 to that 150 ohms, you will have equivalent to 1 kilo ohm, enough to carry the total current flowing to each of the 7 LEDs. So that's the simple illustration. 7, okay, multiply that times 7, you have approximately 10,050. So we can use 1000 ohms or 1 kilo ohms. Okay guys, actually you can also use 150 ohms as limiting resistors in each of the individual LED if you do not have a 1 kilo ohm. So this one will be connected directly to ground, and you have each of the LED 150 ohms. So for simplicity, I choose to use 1 kilo ohm in this portion. Next thing we need to find out is pins for each of the segment of the 7-segment display. Here we have the A, B, C, D, E, F, G LED of the 7-segment. So if you look at the datasheet for this module, you will find pin 11 for A, pin 7 for B, pin 4 for C, pin 2 for D, pin 1 for E, and pin 10 for F. Pin 13 is for the decimal, but we will not use this one. So these pins will be connected directly to the Arduino pins. So as you can see, there are 4 displays. So it means that this segment is also in parallel to the segment, in parallel to the segment, and in parallel to the segment. So these segments are supplied with this pin. So and the same with other segments. So these 4 segments are, or 4 displays are connected in parallel. So you only need to supply a voltage in these pins and connect this to ground, then all these pins will light. If you connect only this one pin to ground and the rest of the 3 pins are not grounded, then only this first segment will light. So if you do this in the second cathode, you connect this to ground and the other 3 pins are held high or not connected to ground, then only this one will light. The 3 other segments will be idle or no power. So this is now the connection from the 7-segment pins. So this will be connected to the Arduino pins. We will see later which pins of the Arduino that we will be using for all of these pins and these 4 pins. Here you can see the LED, the 3 push button pins and the pull down resistors. This one is the limiting resistor for this LED. So this LED will be used to indicate the second of our digital clock. This resistor we will use 220 ohms. So for computations, just follow this formula. Actually, its good resistor is 150 ohms, but the 220 ohms is also good for limiting resistors. it has an approximately 18 milliamps, which is within the range of the LED. So then for the 3 push buttons, this is the connection. If we pull down these pins, 3 pins are connected to the Arduino pins, and a pull down resistor connected here. Basically this is 10 kilo ohm. The same with this one. Kilo ohm. Then the other pin of the switch is connected to the 5 volts supply of the Arduino. So this ground are connected to the ground of the Arduino, including this ground connected to the ground of the Arduino. So the operation of this switch is very simple. As you can see in the diagram, once the switch is held open or not pressed, the Arduino pin will be grounded, but through a 10 kilo ohm, not to damage your Arduino pin. And once the pin is the push button is pressed, then the Arduino pin will be supplied with the 5 volts, and it will read as high. So if it is released, it will held as low. So later on in our program, in the next video, we will see in details the program of our digital clock. So for now, we will discuss in details the circuit and the connection. So we have also the last component, so the DS1302 module. So it has 5 pin outs. So this one will be connected to the 5 volts of our Arduino, and this one will be connected also to the ground of our Arduino. These 3 pins will be connected to the pins in our Arduino. So this CL key is used to synchronize the movement of the data. So this pin, the data or the IO, it's a bidirectional pin. If you want to send data to this module, or you want to send data from this module to the Arduino, you use this data or this pin. This pin, the RST, tell the module if it will receive a data or it will send a data. So all these pins will be connected to the Arduino. Now we will discuss the pin numbers from the Arduino to each of the pins in our circuit. So this is now the pin numbers of our Arduino, and these are the assignments of our pins in the circuit. So for our push buttons, they will be connected to E4, E1, and E2 pins. This LED for our second indicator be connected to 0 pin. These 7 segments will be connected from E3, 1, 2, 4, 7, 8, and 12 accordingly. Then these 4 pins will be connected to 6, 9, 10, 11 of the Arduino pins. For DS1302, these 3 pins will be connected to 3, 5, and 13. So I'll show you the program, the connection, and the assignment of pins. So here I use the 3-wire library and RTC DS1302 library, 13, 5, and 3. Then digit 1, 2, 3, and 4, the 4 display, 7 segment display, 11, 10, 9, and 6, 7 segments, A3 to 12, and the dot which is assigned to 0 is for our LED for the second, and the 3 switch A0, A1, and A2. So in the next part of this video, we'll show to you the details, more details of this program. We will talk about the software of the digital clock. We will proceed to the connection in the breadboard. Oh guys, this is now the complete connection of our circuit to the Arduino pins and to each of the modules and parts. So here the 1 kilo ohm limiting resistor for the each of the segment connected to pins 11, 10, 9, and 6. So just refer to this diagram. Our push buttons, LEDs. So all things are set. Let's try it. I will try to compile the program to the Arduino and see if it will work. So let's try to upload our program. So it's now working. We will set the time. Set the time. We will use the push buttons. Select. Time now is 5:34 p.m. So 5:44 must be 0. Next is set this to 5. 5. Then 34. 3. Then 5, and the date, month is April, so April 30. We can only set this 20. So that's it. That's the time. That's the time now, 5:36. LED for the seconds. Let's see if the date will scroll in around 40 seconds from now. Okay. I think the digital clock is working correctly. So thank you guys for watching. See you in my next video. Please subscribe. Thank you.